Future Trends in Chemical Warfare. Title: Future Trends in Chemical Warfare, Challenges and Emerging Threats. Introduction. Chemical warfare has a grim history that dates back to the ancient world, but modern technological advancements have the potential to reshape the landscape of this deadly form of warfare. As our understanding of chemistry and its applications continues to evolve, so do the capabilities and complexities of chemical weapons. The future of chemical warfare presents a myriad of challenges and emerging threats that demand vigilant attention from the global community. Historical context and evolution. The use of chemical agents in warfare is not a new phenomenon. From the use of toxic smoke in ancient battles to the chlorine gas attacks during World War I, chemical weapons have left a lasting impact on both military strategy and humanitarian concerns. However, the Chemical Weapons Convention, CWC, of 1993 marked a significant step toward curbing the use of chemical weapons, aiming to eliminate their production, stockpiling, and use. Despite these efforts, the threat of chemical warfare remains, and it has the potential to take on new dimensions in the coming decades. Emerging trends and challenges. 1. Advanced delivery systems. Traditionally, chemical agents were disseminated through simple means like artillery shells and aerial bombs. However, future trends indicate a shift towards more sophisticated delivery systems, including drones, unmanned vehicles, and even cyber attacks targeting industrial facilities. These advancements enable perpetrators to reach remote or heavily fortified areas, challenging traditional defense strategies. 2. Non-lethal chemicals. While the focus has been on highly toxic agents, the development of non-lethal chemical agents is an emerging trend. These substances could incapacitate individuals without causing permanent harm, offering an alternative to lethal force in specific scenarios. However, the ethical considerations surrounding their use and potential misuse raise complex questions. 3. Hybrid warfare. The integration of chemical warfare with other forms of warfare, such as cyber attacks and disinformation campaigns, presents a potent challenge. Combining chemical attacks with disruptions to communication and infrastructure can magnify the impact and complicate response efforts. 4. Dual-use technologies. The proliferation of dual-use technologies, which have both civilian and military applications, poses challenges for monitoring and control. Technologies that were initially developed for peaceful purposes, such as industrial processes or medical research, could be repurposed for the production of chemical agents. 5. Synthetic biology and designer agents. Advances in synthetic biology allow for the creation of custom-designed organisms and molecules. This opens the door to the development of designer agents that can be tailored to specific targets or scenarios, making them harder to detect and counteract. Mitigation and preparedness. Addressing the evolving landscape of chemical warfare requires a multifaceted approach that includes international cooperation, robust defenses, and preparedness strategies. 1. Strengthened international cooperation. The Chemical Weapons Convention remains a cornerstone of efforts to prevent the use of chemical weapons. Countries must continue to collaborate, share intelligence, and improve verification mechanisms to ensure compliance. 2. Enhanced detection and monitoring. Advancements in sensor technology and remote sensing platforms can aid in the early detection of chemical attacks. Rapid identification of the agent and dissemination method is crucial for effective response and mitigation. 3. Improved protective gear. Developing advanced personal protective equipment, is essential to safeguarding military personnel and civilians. Lightweight, breathable, and highly effective can reduce casualties and minimize long-term health effects. 4. Public awareness and education. Educating the public about the dangers of chemical warfare and how to respond in the event of an attack is vital. This includes informing individuals about protective measures, decontamination procedures, and early warning systems. 5. Research and innovation. Ongoing research into antidotes and medical treatments for chemical exposure is crucial. Developing rapid and effective treatments can significantly reduce the impact of chemical attacks. Ethical and legal considerations. As technology evolves, so do the ethical and legal considerations surrounding chemical warfare. Striking the balance between innovation and responsible use is essential to prevent misuse and the violation of international norms. 1. Ethical use of non-lethal agents. The development and use of non-lethal chemical agents raise ethical dilemmas. The international community must define clear guidelines for their deployment to prevent their misuse in ways that could still result in severe harm. 2. Dual-use technologies regulation. Governments and international organizations must collaborate to establish stringent regulations for dual-use technologies. This involves balancing the benefits of scientific advancements with the need to prevent their exploitation for malicious purposes. 3. Transparency and accountability. Ensuring transparency in research and development related to chemical agents is critical. Institutions involved in chemical research should adhere to strict codes of ethics and be accountable for their work. Conclusion. The future of chemical warfare is characterized by both challenges and opportunities. As technology progresses, so does the potential for devastating attacks that can cause harm to both military personnel and civilian populations. International cooperation, innovative defense mechanisms, and ethical considerations will play a pivotal role in shaping the outcome. By staying vigilant and proactive, the global community can strive to prevent the misuse of chemical agents and work towards a safer and more secure world. Emerging threats and countermeasures. 1. Nanotechnology and microencapsulation. The convergence of nanotechnology and chemical warfare introduces new avenues for both threat and defense. Nanoparticles can enhance the delivery and persistence of chemical agents, making them more potent and harder to detect. Conversely, nanotechnology can also be employed to create advanced filters and barriers that effectively neutralize or mitigate the impact of chemical agents. 2. Genetic targeting. The manipulation of genetic information can potentially lead to the development of chemical agents that target specific genetic traits. This raises concerns about the potential for personalized chemical attacks based on an individual's genetic makeup. Countermeasures could involve the development of genetic therapies that could neutralize the effects of such agents. 3. Artificial intelligence, AI, and machine learning. AI can aid in the design of novel chemical agents by predicting their properties and behaviors. On the defensive side, AI-powered systems can rapidly analyze data from various sources to detect and respond to chemical attacks in real time. 4. Decontamination strategies. Developing efficient and cost-effective decontamination methods is crucial for minimizing the aftermath of a chemical attack.